Welcome all. Today we are going to learn about PN junction. As we have discussed in the last class, we know that a P material is like this. If this is a P material, then it has got a lot of free holes due to doping and also some minority carriers due to temperature, room temperature I should say. Then there will be a lot of immobile negative ions. Immobile negative ions. So this is P. And a little amount of free electrons due to temperature. This is what is inside a P material. That is a lot of holes, free holes. These are all free holes. And this is immobile negative ion, and this is free electron. And remember, these free electrons are due to temperature. And in the end part, what happens is, what are the constituents inside the end part? There are a lot of this is N, lot of free electrons due to doping and also due to rise in temperature. And for all these electrons due to doping, there will be positive ions. There will be positive ions. Okay. And there will be few holes due to rising temperature. There will be very few holes due to rising temperature. And these holes here are minority carriers, and here these electrons are minority carriers. Okay, so this is here, this is immobile positive ion. Okay, the rest is okay. And this is a P type and this is N type. Now we had to see what happens when these P and N are joined together. Let us see what happens then. We are connecting P and N together. We know in P there are a lot of free holes. This is P, this is N. There are a lot of free holes here. In the inside, there are a lot of free electrons here. And there are a lot of immobile negative ions here. Immobile negative ions here. As I told you, there are a lot of immobile electrons here. Here there are a lot of immobile positive ions. And a very few minority carriers as holes here, and here also a few minority carriers. And as soon as this junction is formed, these are connected together, what happens is, at this area, these holes and these electrons very near to the junction, these electrons will move towards these holes and recombine there, and the holes here will move towards this part and they will recombine there. That means that will cancel each other. ഈ ജംഗ്ഷനോട് ചേർന്ന് നിൽക്കുന്ന മെജോറിറ്റി കാരിയേഴ്സ് അങ്ങോട്ടും ഇങ്ങോട്ടും പോയിട്ട് ക്യാൻസൽ ചെയ്യും. So any electron coming from this end part, this region to this region, will move towards here and they will cancel with these holes. And some holes, mobile holes, free holes will move from P to N and they will recombine with. Recombination is the process of cancelling positive free electrons and free holes each other. And what happens at the end is, what happens is, there will be a region in which there is no free holes or electrons. There will not be any free holes or electrons. Here there will be only immobile ions. There will be only immobile ions. No free, nothing uh, free carriers there. Only immobile ions. So what happens? These immobile ions, it is free of mobile carriers or free of electrons or holes. So this will act as, this is depleted of charge carriers. So this is known as depletion region. Depletion region. At this time, no more holes from P can travel towards N region, and no more electrons from N region can pass to the P region. This will act as a barrier. And there will be a potential there. This is positive, this is negative charge, and that potential is known as barrier potential. And this will act as a barrier means മലയാളത്തിൽ പറഞ്ഞു കഴിഞ്ഞാൽ ഒരു മതിൽ പോലെ ആക്ട് ചെയ്യും. ഈ ബാരിയർ പൊട്ടൻഷ്യൽ വന്നു കഴിഞ്ഞാൽ പിന്നെ ഡിപ്ലീഷൻ ചെയ്യാൻ വന്നു കഴിഞ്ഞാൽ പിന്നെ പി ടൈപ്പിൽ നിന്ന് ഫ്രീ ആയിട്ടുള്ള ഒരു ഹോൾസും എൻ ഭാഗത്തേക്ക് പോകില്ല, എൻ ഭാഗത്തു നിന്ന് ഒരു ഇലക്ട്രോൺസും പി ഭാഗത്തേക്ക് പോകില്ല. ബിക്കോസ് ദിസ് റീജിയൻ ഈസ് ഓഫ് ഇമ്മൊബൈൽ അയോൺസ്. they cannot move. Okay, they are depleted of charge carriers ഒന്നും ഈ ജംഗ്ഷൻ ഭാഗത്ത് ഉണ്ടാവില്ല, ഈ ഡിപ്ലീഷൻ റീജിയൻ ഉണ്ടാക്കില്ല. So this barrier potential is 0.7 in case of silicon and 0.2 to 0.3 in case of germanium. Okay, this is the barrier potential in this region. So this is the PN junction in ideal condition. That is in ideal condition. That means there is no external potential or external bias given. Just when P and N material are joined together. We know that there are few minority carriers, some electrons here and some holes here. They will travel. This is only very few minority carriers. There is a few minority charge carriers, that is a few nanoampere. And these electron and holes will not combine each other here because of difference in energy level. Because of the difference in energy level, the minority carriers and majority carriers within a region won't cancel at that instant itself. They will cancel after a long time because of when the energy is equalized, they will recombine each other. Okay, so this is the condition of PN junction when without any biasing. Okay, the next class we will learn about what happens when an external bias, when an external voltage is applied across this, and this PN junction, this is P and this is N, and in short this is nothing but this symbol is like this, and this is known as a PN junction or a diode. This is nothing but a diode. This is anode, this is cathode. Okay, thank you for now.